So hello everyone, I hope you're having an amazing day, and I'd like to welcome you all here today to have a webinar about how to build bank products and how we build them with Thought Machine. Before we begin with the webinar, I would like to have a quick introduction so we get to know ourselves. So I am Veronika and I work as a software engineer in Vacuumlabs. I focus mostly on the development of financial products and mainly in collaboration with Thought Machine. And every topic we will discuss here today, I will try to bring a technical point of view and describe what our experiences with the bank product development are. And to cover the topic also from a more business-like perspective, Paul Kenny is here with me today.
Hi, Veronika. Hi, everybody. My name is Paul Kenny. And just to give you a little bit of background about myself, I've worked as a developer. I've worked as a product manager. I've worked in both startups and large corporates. And I've even gotten to run a fintech business within a telco. I love my job at Vacuumlabs because I get to work with clients who have great business ideas, lots of energy, and we get to help them to build new tech ventures. So, hi, everybody.
Thank you, Paul. So, let's move on to today's agenda. The first two parts of the webinar will look at what the development of financial products looks like currently. We will look at the banks and state of banking in general, and then we will look at what the core banking systems are. And then we will move on to a more kind of practical part of the webinar, and we will share our experiences in how we develop the banking products. So I think we can begin. So let's begin with the first part of the webinar, and let's talk about what the financial products development looks like. So Paul, you have been in the fintech industry for quite some time now. So how is it evolving according to you, and what is the current state of banking, and what do the financial products look like according to you?
Okay, thanks, Veronika. So they used to say that banking was 363. So you would borrow money at 3%, lend it out at 6%, and be on the golf course by 3. But obviously today banking is a little bit different. It's 365, 365 days a year, and it's 24/7. Customers expect to be able to bank when and where they want and to get the services they need via their preferred channels. So the challenge with that is that legacy banking services were designed for a world where banking services stopped at 3 p.m. and the services themselves were administered by tellers and bank managers in a branch. But today, if customers are expecting services to be available 24/7, they don't want to go to a branch. They want to get the service on their mobile, on their iPad or their computer. And they expect their funds to be extremely secure, obviously, but they also want them to be easy to access. So there's a little bit of a tension there. And they want to be able to perform transactions and apply for new services with just a few clicks. On the business side of the people in the bank, they need flexibility. So they want to be able to respond to market circumstances quickly, whether it's as a result of competitor actions or market conditions, for example, changes in interest rates, or both. So it's an exciting time in banking, which is not necessarily a good thing because the increase in interest rates have resulted in lots of pressure on banks. We've seen that a lot recently. And there have also been new entrants into the banking market where you've got companies like Apple who are introducing new savings accounts and new services like Apple Pay Later. So there's a lot of stuff happening that banks need to respond to in order to be competitive around new services, around new regulatory initiatives like open banking and so on and so forth. Now, all of these services need to be logically integrated from the customer perspective and from the business perspective so that the customer and the business can get a single overview. But ideally, they also need to be technically separate and modular, right? You don't want a big monolith. You don't want a lot of spaghetti code because it becomes too difficult to maintain over time. So the fact is that banks are not really that flexible in the kind of products they offer and the speed of getting to market. So to give you a couple of examples. So when the COVID pandemic hit and we went into lockdown and the bank said that they would allow people to have a mortgage or a loan repayment holiday, it took a long time for several of the banks to implement that. That was because their systems were quite inflexible. And similarly, if you think about the product you have or the products you get from the bank, they're all quite discrete, right? So you have a deposit account with a debit card attached, you have a credit card, and you have a separate loan account, say. So why doesn't a mainstream bank offer the ability to convert, for example, your credit card balance to an installment loan within just a few clicks? Again, it's because of the discrete nature of the systems. And why is it hard to offer new products, such as offering offset loans, where you can use the deposit on your account as pseudo collateral against your loan interest, right? The point is that, all of these systems within legacy systems are quite discrete. It's very difficult to get them to work together. Whereas if you're looking at modern cloud banking platforms, like, for example, Thought Machine, that we're going to talk about more today, they offer a lot more flexibility. So using smart contract technology, banks are able to design and build their own financial products, which are 100% customized and not restricted to predefined templates. So today, we're going to talk specifically, or rather, Veronika, you're going to talk about the challenges of adjusting an in-market financial product and showing how we at Vacuumlabs did it using smart contracts on Thought Machine's Vault product. And we're going to do that within the context of a modern microservices-based architecture and demonstrate how this is an improvement over a legacy core banking system. So back to you, Veronika.
Thank you very much, Paul. Yeah. So as you said, I really agree that banking has come a long way. And basically, we have a great variety of banking products, deposits, loans, savings accounts that I'm sure that every one of you, the people that you are watching this webinar right now, use every day. And I think it's really great because you basically can access your money anytime directly in your hand. But and it's great when things work, right? And you don't have any issues when accessing your money. But of course, there is usually much more under the roof. And all the banking products that we currently have to have their behavior defined somewhere and somehow. They have to be implemented somewhere and somehow. And that's basically a place where many complications begin. What I mean by the implementation is that, for example, if you have a loan account with automatic monthly repayments, the repayments need to be processed, they need to be scheduled, they need to be run, right? Or if you have an overdraft account and you are performing a payment and you don't have enough money, there have to be some kind of mechanism that is implemented in the background which evaluates if you can use the overdraft. And this is the complicated part for us engineers, because how and where do I implement this logic so I can rely on it? And this is the part where many complications or pain points appear. And that's also what we are going to talk about a little right now. What are the pain points of the financial products development? But before I will talk about the worries that I have as an engineer from the engineering point of view, Paul, I would like to get back to you and ask you about what do you see as hurdles, worries, or pain points of the development of financial products. Can you maybe provide us some examples?
Okay. So if you think about a product system in a legacy environment, there's a limited number of product parameters that can be configured. So it might be the basis for accrual, the payment calendar, the holiday calendar, and so forth. So if a new product requires another parameter, it often has to be hard-coded by the vendor or programmed in by the bank's IT team. And many of these systems operate by defining a product code, right, which is a combination of these pre-selected parameters. So this means every time you change something, you have to have a new product code. And those product codes often need to be replicated in different systems so that, they're aware of any impacts as a result of those new codes. And those systems themselves are quite siloed, right, and quite product-centric. So it becomes really difficult to launch and support a new product whose parameters cross those traditional product boundaries. So the example we talked about earlier around offering a loan with a rate linked to a balance in your mortgage account, like an offset mortgage, is quite difficult to implement in a legacy system. So what about from an engineering perspective, Veronika? What do you see as the key pain points?
Thank you, Paul. I think you provided great examples. And from the engineering perspective, to be honest, there are many pain points usually because, banking products and the whole technical environment is complex. And if I should sum the worries that I have in some kind of categories, I would probably call the first one a worry about reliability. And I need to trust the technology because we are working with real people with real money, and we don't want to work with technology that would cause our bank to go offline for 1 week, and we would have no idea what's causing it to be offline. We have bugs in production, we don't see them, we can debug them easily, and we are not notified about the bugs, for example. We when we are working on a bank product, I really want to be able to rely on the technology. I want to be able to rely on the monitoring that I have in production. I want to know when something is happening so I can quickly analyze what's wrong and fix it, and I can just work together with the technology and have the big amount of reliability on it. So that's the first worry, to be able to rely on the technology. Then the second worry is something which I call as having control over changes. And this stems from that bank environments are usually complex. And that's especially also for the legacy systems, which were usually highly coupled with many components or parts. And in case you want to add a new functionality or you want to change an existing product, you may cause a domino effect. So you change one thing, and then the connected components are basically also influenced by the change, and you are kind of rolling the change over the whole banking environment, and you cannot control it because everything is highly coupled, and suddenly your bank is offline. This is something that I don't want to do. I want to have control over when I'm creating something or when I'm making the change. I want to be able to properly say what is the effect of the change. I want to be able to capture all the changes and test them properly, and therefore I have the control over what I am doing to the system. So that's the second pain point or a worry that I have. And the third worry that I may have is the compatibility, which underneath which is, how easily am I able to translate the business requirements to the language of the technology or to the implementation. So in future, in case I will be, because the bank is changing and the products that you are developing are also changing over time. And in future, if I'm about to do a change or implement a new product, I want to be sure that my technology supports me and does not limit me. So I know that I can rely on the fact that if I should add a custom feature to the product, I will just take my technology, translate the feature into its language, and without the limitation and with support, and I will be able to roll out the change as smoothly as possible. And these are the worries that also the developers or creators of modern core banking systems of now do realize as well. And the nice thing is that the modern core banking systems help us or with these challenges or aim to mitigate the challenges for us. And that's the thing that we are going to talk about for the next part of the webinar. So to you who are watching this webinar right now, this also may be a place for you where you can stop for a while and also think about, if you have an experience with the development of bank products, what the pain points of the development of the financial products were for you. What do you see as the challenges or the worries that you have when developing the bank products? And for us, we are going to move on to the next part of the webinar, where we are going to talk about the core banking systems of now. And as we said, the modern core banking systems aim to help us with the development challenges that we have. But before we actually look at how they help us, let's talk about what even the core banking systems are. And here I would like to go back to you, Paul. If you could provide us maybe more of a human language explanation of what the core banking systems are and what are their roles and functions.
Oh, okay. Thanks, Veronika. So what we've got on the screen here is a very nice schematic which was produced by McKinsey, which looks at the kind of the structure of a modern bank. And if we think about it, sort of looking at it from a customer's perspective, the first kind of point of entry is going to be via the application, right? So it's going to be via a mobile app or via a desktop app. And you also have the legacy systems around branch and call center and so forth. And then within that, you're going to have these other services, right? So there might be risk management. Okay, so that would include things like KYC, know your customer, where you have to verify that the customer is who they say they are. And you might want to do some sort of credit check. You might want to do some sort of anti-money laundering check to make sure that the person isn't trying to launder money. And then obviously you need to have integration with payments. So are you using a card? What kind of network is it on? Are you making a transfer domestically or internationally, and so on? And then you also have the customer management system. So these are the systems that the bank will be using to to help identify the customers, to track their relationships with the customers, to market to the customers, and so on. And then more broadly, you've got the kind of ecosystem of services that you might be offering, which could include internal systems like finance and accounting, right, to allow you to kind of manage your overall bank. And then at the center, you have the core itself, right? So that is the piece that performs three key functions, right? So one is to provide a general ledger, which is obviously the kind of the key function of the core, to give you an exact view at any point in time of the status of each of the accounts. You may also use that to keep core customer data, right? All of the transactions and so forth about that customer. And you also use it to store product information, right? So that could be the definition of the products that you're offering, whether it's a term loan or a deposit account or a current account and so forth. And so if we think about this in terms of, the differentiation with a legacy system, right? A legacy system will be different in terms of how the products are defined. So if you remember, we talked about earlier, you tend to have predefined products. There tend to be a strict number of parameters and so forth. Whereas with a modern core, it can be hyper-parameterized, right? So you can have lots of different parameters and you get to choose exactly what parameters you want to put in. It's real-time 24/7. So, in the modern core, you have this ability to be able to see all of the data at any time, as opposed to things shutting off in the evening because you need to run batch jobs and so forth. It's obviously cloud-based for a modern core, rather than being something that's running off a mainframe and that's sitting on your premises. And often we're using APIs to communicate with these, right? So it makes it much easier to integrate third-party services or to expose your services to third parties to enable you to start offering banking as a service style services to third parties. So those are really the key differences. Veronika, if you're thinking about this as an engineer, what do you need from a core banking system?
Thank you, Paul. You provided a great explanation of what the core banking systems are. And if I should continue from the engineering point of view, I think that the things that I expect from the core banking systems are also related to the worries that I have as an engineer, like what might happen when developing the financial products that we already talked about today. And I want to be able to rely on the technology of the core banking system, so it provides me a great level of monitoring, observability, transparency, what's happening in the bank, what's happening with the accounts, with the money of customers, and supports me during the deployment and testing of the product. And from the functionality point of view, I also, as an engineer, wanted to manage the financial state of the bank for me in real time. What I mean by that is that I, as an engineer, I want to be able to say that these are the money movements in the bank right now. These are the payments, transactions on these and these accounts, but I don't have to care about that these will reflect correctly to the I don't have to handle the translating of the money movements that I enter to the system into the actual state of the ledger, because that's something that the core banking system handles for me in real time. So I can just say that these are the money movements that are happening, and the core banking system will automatically manage and update the financial state of the bank for me. So I anytime can query the financial state and know what is the state of the money in the bank. Then also other responsibility or function that I want from the core banking system is to be, of course, be able to define and rank bank products logic. And I, as an engineer, want to focus on the part that ensures that I am able to correctly translate the business requirements into the product logic, and how to translate them, the technology itself, or how then the logic is run. That's something that I leave to the core banking system that will help me with, so I can more focus on the correctness of the product. So to sum up, it should serve the function of the ledger, real-time ledger. It should help me to define and allow me to define and rank easily bank products logic, and it should be a reliable technology that I can have a great monitoring state over and know every time what's happening. But also, when it comes to the implementing specific products, there are many other functional requirements that I have on the core banking system, which I usually determine according to what I am implementing. So for example, if I know that I am about to implement a loan that allows customers to have custom repayment schedules and different interest rates and different behavior related to the custom schedules, or I am implementing a product which allows customers to take overdraft with different limits and repayments plan for each customer, I know that I need my core banking system to allow me a high level of account parameterization. So I am able to track differences from customer to customer in setting of the accounts. And also I am able to adjust the account behavior with the custom logic based on these values or differences. Then, for example, if I know that I am going to implement a loan account or savings account that has daily accrual of interest, or maybe on monthly basis gives my customer bonus interest based on some kind of incomes during the last month, I know that I need a scheduled behavior. So I want my core banking system to support me in implementing events that should be scheduled automatically, that have the access to the current state of the account, so they can adjust the behavior of the schedules, and I can even implement the custom behavior within the scheduled events for each customers. And then lastly, if I know, for example, that I am going to implement an account which, when there is a new money incoming to the account, can block the funds in case that the customer has an existing debt, or maybe I have a custom behavior related to the payments that are incoming to the account or outgoing from the account. Like, for example, I want to provide immediate 5% cashback on current payment if customer fulfills some conditions. Then I know that I need a core banking system that allows me to react to payments and react to payment in a way that I can define a custom behavior, what should happen when there is a payment currently on the account. So that's kind of a thought process that I have. When I know what I am about to implement, I can derive what I probably need from the core banking system to support me with.
Thank you, Veronika. So as we mentioned earlier on legacy systems, it often becomes difficult to customize products, and you end up with lots of different product codes. And it's also difficult to mix and match different kinds of products. For example, the offset loan account that we talked about with the current account balance. And it feels like that a lot of the things that you are talking about that you get or that you expect from a core banking system is something that in a modern core system is going to address a lot of those concerns. So, Veronika, maybe you could tell us how you actually go about implementing those products then on Thought Machine's Vault Core.
Yeah, thank you, Paul. And yeah, let's move on to the next part of the webinar, which will now focus on providing you the experiences that we have with the actual implementation of the bank products that we do in Vacuumlabs. And for that, we use core banking system from Thought Machine Vault Core. So right now we are going to explain what the Thought Machine Vault Core banking system is and how we use its mechanisms, its smart contracts that we're going to talk about later to actually implement the bank products. So what is the Vault Core core banking system? It is a core banking system by Thought Machine that mainly serves the two functions. It is an universal product engine, meaning that it helps me and it allows me to define and run the account, the financial products. And the second function that it has, it's being a real-time ledger. So it manages the financial state of the accounts. It is the single source of truth for the financial state of the bank, and it manages it is the ledger that works in real time. And the Vault Core is integrated to the rest of the system with its APIs, which is either streaming or REST API. Since Vault Core is a centerpiece and standalone component of our architecture, we are going to also show you maybe what a simplified view on the architecture that we usually build around the Vault Core, what it looks like. And as you can see, we have the Vault Core in the middle, or at the bottom in this image, which implements the product and serves the function of the ledger. Then we usually have a layer above or around the Vault Core, which is the layer that consists of microservices. The role of the microservices is to provide the connection to the third-party integration, so to connect our core banking system with the rest of the world. For example, if you have any KYC systems, you can connect with your microservice to it, get some third-party data, and then enrich the behavior of your bank products implemented with Vault Core. Other role of the microservice is also to trigger the account behavior. So to trigger the account lifecycle, for example, open the account in the Vault, close the account, maybe forward the payments to the Vault Core, or just trigger any part of the lifecycle of the accounts that the account may have. We are going to also talk about the responsibilities and the functionalities that the accounts can have later. And the last layer that we can see is the front-end layer, which is what customers and the bank workers interact with, which is the mobile app and the back office app for the bank. And also when there is a customer that interacts with the mobile banking app and, for example, enters some payments or triggers some account functionalities, the triggers or the functions that the customer want to perform are then forwarded to the microservices, which then forward them to the account implementations in the Vault core banking system. All of the layers are somehow connected to the actual bank product. So when we are talking about the product itself, within the architecture that is built upon the Vault core, the meaning of the product is usually its implementation in the Vault core and its financial state in the Vault core, together with its microservice that provides the third-party data and triggers the account lifecycle and functionalities.
So now we know that the product is within Vault, but where is the actual product logic written, Veronika, and how do you define it within the Vault core?
Yeah. So, of course, somehow you need to get from having the core banking system to actually having a working app which people can use, and the logic of the product needs to be implemented somewhere. And that's exactly what the smart contracts by Thought Machine are for, and we also use them to implement the bank product. Just before we move on to an explanation what the smart contracts are, I would like to add one disclaimer that I'm sure that many of you that you are watching this webinar right now know the word smart contracts from the crypto world. Thought Machine smart contracts are not equal to the crypto smart contracts on blockchain. They share the name and they share the principles of being able to react to payments and evaluate of what should happen, but we are not going to talk about the crypto or blockchain world right now. We are purely staying in the fintech environment and in the banking systems. So, what then the smart contracts are? Smart contracts are Python-based code snippets that allow me to define the logic or behavior of bank accounts or bank products. So, before we move on to a further explanation, you can see that I have a screenshot of a smart contract code actually here. What I want to say by that or show on the screenshot is that the code is written as reactions in the events. So you can see two functions there, which is pre-posting code and post-posting code, which are called hooks. It's functions that contain a definition what should happen when there is an incoming payment or outgoing payment to the account immediately before the payment or immediately after the payment. And this is the principle how smart contracts are written. There are many things that I can react to on the account, or that are part of the life cycle of the accounts, and I can write my own behavior or reaction, what should happen when an account is opened or when there is a payment. So the code is trigger-based. It's important to notice note that the accounts or smart contracts have access to real-time and past financial state, so I can use the state to write the logic and evaluate some things, for example, on the accounts in real time. And the smart contracts are being deployed or uploaded to the Vault core as a configuration. So in case you are about to add a new account, a new smart contract, or update an existing account, you don't have to redeploy the whole Vault core. You will just deploy the new version of the smart contract. You will just put a new code into the Vault core and you have a new product or updated product. So it's a configuration to the vault core, and then it's the code that defines the logic or the behavior of banking products.
Veronika, you mentioned on the slide that an account is an instance of a smart contract. Could you elaborate on that and just explain what that means?
Yeah. This means that you only need to write one smart contract, one code, to be able to create multiple or as many as you wish accounts for each customer that can be parameterized from customer to customer. But you have one base smart contract, one code definition, and then you have many real life instances of the behavior, which are the accounts basically, which can differ from the account to the account with parameters. That's what I mean by that.
Thank you.
Okay, so when we were talking about that, we can define the behavior of the bank products with smart contracts. There are multiple areas of behavior that we can define. And the first one is the account lifecycle, which we have mentioned already quite a few times within this webinar. So basically, we can use the code and write the code to define what happens at the time of when a new account is open, when an account is closed, or maybe when a version of the account is upgraded. Then the second area of behavior that we can define is what should happen when there is a payment on the account, which already was showcased on the slide before on the screenshot as well. So that means that I can even evaluate if I want to accept or reject the payment, or if there are some additional actions that I want to take immediately after a new payment is accepted. I can also define this logic with the smart contracts. Then smart contracts allow me to parameterize the accounts. So what are the differences in between the accounts, and what should happen when, for example, if I have a parameter to the account, if the value change, how the account should react to it. For example, if each account has a different interest rate, what should happen when I change an interest rate of a given account of a given customer? And that's also what I can define with the smart contract. And then there is the scheduled behavior. Besides of a reaction to the external triggers, smart contracts also react to time or time events, which basically allows me to implement the scheduled behavior. So I can define what should happen automatically every first day of a month, or every evening at 8 o'clock, or at any specific time in the future. These are not the only functionalities or areas of behavior that I can define with smart contracts, but for the purposes of this webinar, we are going to focus mostly on these main areas. And as I said, all of the behaviors are triggered by REST and streaming APIs that Vault Core offers.
Very good. So if I understand it correctly, Veronika, you're saying that you can control every action programmatically within a smart contract, right? That's incredibly powerful. So it means you get to completely define the customer experience.
Yes, that's correct. And I as an engineer, I really like the flexibility, because if I want to model something or program something, I want to model the smart contracts or the account behavior, I am not limited to like predefined set of options to choose from. I can just write the code and implement the logic in a way that I like. That's nice. Yeah.
It's pretty good as a business person as well, right? Because it means that, you get to completely define the product that you want, rather than being sort of forced to take something that's off the shelf or predefined.
Yeah.
So what's next, Veronika?
Yeah. So because one time to try something is better than read about it for 100 of times, we are actually going to show you how we design and create the product with smart contracts. So let's design a banking product as a smart contract. We are going to imagine that we have a bank, and within our bank, we want to implement a simplified product, which is called Super Credit Limit Account 1.0. And this account has two simple functionalities. It allows customers to perform payments, so to either send payments to the account or send payments from the account. And in case that customer doesn't have enough money to perform the payment, the customer has an option to borrow the money for the given payment from the bank. And they have a limited amount of money to borrow from the bank for the payments, which is the maximum monthly credit limit that they can use. And in case that customer uses this function and they do borrow some money from the bank to be used to help with their payments, they are obliged, they have to repay the money at the beginning of the next month, which is supposed to be performed automatically. So these are the two main functions of the banking product that we are going to implement. Of course, this bank product is really simplified. So in real life, usually the product would be more complex that would to offer a similar functionality, but this simplified version is just for the purposes of this webinar. And once we learn what are the mechanisms or the principles behind translation of these requirements to the smart contracts, you can easily apply them to even more complex functionalities or features that you would like to have on your bank product. So let's do it, and let's design the smart contract. When designing a smart contract, we usually look at two main areas of functionalities or characteristics of the smart contracts. The first one is the configuration. So that's basically the description of the characteristics or of the accounts that are supported by the smart contract. Within the configuration, we will today design parameters. So we will design variables or placeholders for the values that will differ from account to an account. Then we are going to design the balances, which represents the money state or the financial states on the account. And if we have multiple balances, they will give a semantic meaning to our money that we have on the account. Every account begins with a default balance, which usually represents the customer funds that are on the account. And lastly, we are going to describe and design the schedules. So we are going to say or define if there is an automatic behavior, scheduled behavior that should happen on the account, when it should be and what should happen. The second area of characteristics that we are going to design for the smart contract and for the account is the behavior. And that's basically the definition, what should be happening on the account is the definition of the product logic. So let's take it feature by feature, and let's look at the first feature, which says that each customer has maximum monthly credit limit to borrow. Let's focus on the first word, which are each customer has the credit limit. This means that I have to have a value that will differ from customer to customer, or it will differ from the account to the account. And for these purposes, I will use the parameters, and I will create a parameter which is called monthly credit limit. This is a parameter which will contain the value, what is the maximum monthly credit limit that this customer is allowed to borrow on a monthly basis from the bank to help with the payment. Then, when I look at the balances, with the parameter, I know for each customer what is the maximum monthly credit limit, but somehow, if customer already did use some part of their monthly credit limit, I need to be able to know how much of the monthly credit they used and how much of the monthly credit I still have left to use for the further payments during this month. For this purpose, I will create a custom address, which I will call used credit, which will be a separate piece of money or separate balance, which I will use to track how much of the monthly credit limit this customer has already spent. Beside of that, I will have the default address, which will contain the customer-owned funds. So that's the money from the payments that customers sent to or from the account. With this, if I have the parameter monthly credit limit and the balance which tells me how much of the monthly credit I already spent, I can do minus in between those two values. I can do monthly credit limit minus the used credit, and every time in real time, I am able to tell how much of the monthly credit this customer already still has left. Okay, and if I know these values, I have to implement the behavior. So I have to allow the customer to actually borrow the money and evaluate at the time of the payment if I should use the money from the bank to help me with the payment. And if we are talking about the behavior, if we are talking about the implementation of this logic, we are moving on to the behavior implementation, which is the hooks or the functions of the smart contracts. The first hook that we are going to implement now is the behavior hooks, which is called the behavior hook, which is called pre-posting hook. The pre-posting hook tells me what should happen immediately before accepting the payment to the account. And its purpose is to actually evaluate if there is a payment which is currently incoming to the account, if I should accept it or if I should reject it. The logic that I need to implement there for my credit limit account is that if there is a new payment incoming to the account, I need to evaluate if there is enough balance, if there is enough customer funds on the account to perform the payment. If the customer has enough funds for the payment, I can just accept the payment, then I don't have to care about anything else, right? But if there is not enough balance on the customer account within the customer funds to perform the payments, I can then ask the bank if the customer still has at least enough monthly credit limit to help me with the payment. If yes, then I'm also able to accept the payment, because that's exactly the purpose of the product that we are creating, that the customer can use the credit limit that they can borrow from the bank to help with the payments. So I will accept the payment and evaluate that, yeah, let's do the payment. And in case that even together with what I have left from the monthly credit limit, I cannot perform the payment, I will have to then reject the payment, because I have no other option how to pay for something that I don't have enough money for. So with that being designed and implemented this way, I am able to, for every payment, to evaluate if I should accept the payment or if I should reject the payment. But now, in case that I accepted the payment, I may have accepted it with the help of the credit limit. So, and in that case, I have to also, after performing the payment, mark down the credit limit that I used for the payment to actually be executed or accepted on the account. And that's something that will happen immediately after the payment is accepted, and it's being implemented in the post-posting hook of the smart contract, in the post-posting part of logic of the smart contract. And here I am going to ask, was the credit limit used for this payment? And if yes, then I will record the used credit. And although I do realize that just saying record the used credit may seem a little bit vague at this point, what this means on the implementation level of the smart contract is that I am actually able to create an internal payment, an internal money movement from the bank side of money to the customer side of the money, or of the finance of the bank, which is the money on the account, which will represent the act of borrowing given amount of credit limit to the customer to perform the payment. So that means that I will implement an internal payment which will send money from bank to the used credit address to increase the balance on the used credit, to mark down that this is the amount of money that I just used from the bank side to help me with the payment. And with that having done, maybe the question could be also that how do I know if the credit limit was used within the payment? And that I can evaluate thanks to the fact that I have within the smart contract access to the real-time financial state of the account, and I can just ask if the balance on the customer address, on the default address that represents customer fund, dropped under the zero because I accepted the payment for which I didn't have enough money for. That means that I temporarily have to drop under the zero so the bank can help me with the payment. And these steps happen atomically in the real time, in really like microseconds. So it's that being done really fast. And at the end of this act, we have the used credit amount marked down on the used credit address. Okay, we are almost there. The only thing that needs to be done now is to repay the borrowed credit limit for the last month in case that the customer used the credit limit. To sum up, we are able to track how much each customer has left as their credit limit for this month. And we are able to evaluate if we should use the credit limit, and if yes, then how to mark it down that we used it. And now we need to implement the last missing piece of the logic that we have, which is that in case that the customer did use some credit limit over the last month, let's automatically repay it at the beginning of the next month. For this, I'm going to look into the scheduled behavior part of the smart contracts, and I'm going to first define a schedule. That means that I'm going to define when should this automatic repayment happen. And the way how I can define this in the smart contract is to define an event, which I will name repay credit, and I will just write a definition that this event should be executed every first day of the month at, let's say, 1 o'clock at night. Right now, if I put this definition into a smart contract, the smart contract will note that every first day of a month at 1 o'clock, it should trigger a behavior. And what is the behavior is something that I will again implement with the scheduled event hook. And here I will look at, or here I will first ask a question. Was any credit limit spent last month? And if yes, I will repay the used credit from the customer funds. And again, this may seem a little abstract at this point, but when we look at the first question, that if any credit was spent last month, I can easily say that or evaluate that because I can just look at the state of the balance at the used credit address, which tracks how much of the used credit customer spent during the last month. And if it's bigger than 0, if there is any used credit limit tracked, I will evaluate this as true, and I know that customer did use some credit limit. And if yes, the repayment can be, the automatic repayment can be realized in a similar way as we mark down the used credit when customer uses it, which is by performing an internal payment from the customer funds or from the customer account back to the bank, which will repay the used credit limit. Of course, for the purposes of, for the showcase purposes of this webinar, we are going to only assume the happy case scenario, so the customer has enough money to perform the payment.
So, Veronika, what happens if the customer doesn't have enough money to repay the credit limit? Or what if we want to add some, additional interest calculations here, need to fold in some taxes? What happens then?
Yeah, it's a good question because we were only assuming the happy case scenario. But in case that, for example, customer does not have enough money to automatically repay the borrowed credit limit to the bank, we can extend these steps that we have here in the smart contract and add a logic that would ask, and does customer have enough money to repay right now the credit limit back to the bank? And if yes, let's repay it. And if not, let's mark down a debt, for example, a separate address that customer still owes some kind of credit limit to the bank. Or if we want to extend the logic for any more, let's say, credit usage fees or interest that will be calculated from how much of the credit limit customer actually used over the last month, we can just extend this behavior to execute multiple steps that would charge the fee to the customer as an internal payment again, or apply the interest to the used credit amount. So it's actually quite flexible that you can model the behavior here in any way as you would like. And the nice part about this is that in a way that I have it defined here, step by step, and definition by definition, I can just take it and one by one translate it into the Python code, into the language of the smart contract. And I have the product definition ready for my accounts to be used. And basically that's all that's left to do at this point, just to take the definition, take the design of the product that we just created and translate it into the Python code.
Okay, Veronika, so what happens next?
Yeah, that's a good question because, of course, right now you have the code, but just having the code in your hand doesn't allow you to create the accounts and, to have a working mobile app that customer can use and interact with and manage their money with. So we are moving on to the next part of the webinar, where we will talk a little about the smart contract development cycle. Smart contracts, as any piece of code or piece of software, have their own development cycle, which we started at the development part. So we designed and created the code, the smart contract, right? But after we have the code, we need to verify if the code actually works. So for that, we are going to begin with unit testing. By unit testing, we mean that we are going to look at the code of the smart contract function by function, and we are going to verify its correctness. So verify it works as intended, it performs the things that it's supposed to perform, and just overall look at the code from the programmer's perspective and verify that it is executed the way it's supposed to and it performs what it's supposed to perform. Once we validate the correctness of the code, we are going to move on to a higher level of testing, which we call simulation testing. And the goal of simulation testing is to validate not only the correctness of the product, but also the correctness of the business logic. So if the accounts behave in a way that we want to, if all the business requirements and functional requirements that we had are fulfilled, and if the overall behavior is correct. An important thing to note here is that the simulation testing allows me to actually simulate the accounts, to run the accounts in a separate sandbox-like environment. So I don't, at this point, I don't take effect on the rest of the banking system. I can just separately evaluate if my products work, and if no, okay, and separately correct the behavior or the bugs that I may have there. And if yes, then I have a verification that my product works as intended, and I can move on to the deployment. I will talk about the deployment a little bit more over the next slide. But after I deploy the product, I can still perform, or I should perform, the end-to-end tests as well. And that's focus. The end-to-end tests are focused on the integration with the rest of the bank environment. So I'm going to create a demo customer, a demo account in my testing environment, and check if the product works in a real production-like environment the way as I intended it to work, and if it also works with a combination with the rest of the banking system, with its microservice, or just with the whole bank in general. And if everything is fine, in case that I wasn't creating a new product, but I actually just updated an existing product, I can also then migrate the existing accounts to the new version. And basically going to production and even migrating the existing account is quite a big step in the life of a bank, because you want two processes to go as smoothly as possible. And this is something that I quite like how it is handled within the Vault core, because I consider their approach quite flexible and allowing me to have control over the deployment. What I mean by that is that when you are deploying a new product, a new smart contract, you are not deploying a new version of the whole core banking system, you are just deploying a new code to the Vault core as a configuration. Therefore, you don't have to go offline with your whole bank and for a week and affect the rest of the banking system in order to be able to update the product or deploy a new product. You'll just deploy a new configuration, and the rest of the banking production environment stays untouched and keeps running as it's supposed to run. Then, after I have the smart contracts deployed, an important thing to note for me is that multiple smart contracts version coexist at the same time, and each account is mapped to one given at the time. And this is actually quite nice, because I can have multiple versions of the same smart contract within the Vault, and I can switch the versions of the smart contract for the account based on my needs. And a great example when this may come handy is when we actually migrate the accounts from older versions of smart contracts to newer versions. Because in order to be able to update an existing product, an existing account for the customers that you already have in your bank, all I have to do is just to say that for this account, let's take every account that is currently supported by an older version of the smart contract and transfer or migrate it to a newer version of the smart contract, so update it. And this is something that happens, like microsecond, and every account by account is migrated. And I don't have to disturb the operation of the whole bank in order to do so. And I am immediately notified if anything after the production goes wrong, so I can react. And this also allows me this also supports me as a fallback mechanism in case something goes wrong, because I can just as easily as I can migrate the account to a newer version of smart contract. In a similar fashion, the same way, I can just take the account which was just migrated to the new version and migrate it to the older version of the smart contract in case the new version has some bug in production or doesn't work as intended. So that's quite a nice feature of the wall that I, as an engineer, like and use, and it gives me some kind of comfort.
I love that feature, Veronika. It's totally different from a legacy system where you'd often have to deploy the entire platform at the same time and potentially take it offline as well.
Yeah, I agree. I mean, the flexibility is quite nice. So, yeah. Okay. And to showcase you that this is actually doable, and we implement the bank products the way how we describe. We took the Python code, or we took the product definition that we just designed here within this webinar, and I created the smart contract from it and deployed it and created a demo account for you to show that that it works, and you can create the credit limit accounts the way how we designed them. So right now I have opened a page which contains the backend part of the account that I created from the smart contract that we designed. It's called Credit Limit Demo, and it has the account ID, and you can see that this is an open account which was opened today, and it is mapped to a product version of the smart contract, which is basically the version of the code that I created and deployed to the Total machine, Vault Core. When we look at this page, we can see a section that's called Account Balances, which is the balances that we designed. That it's the semantics of the money that is on the account, and we can see the use credit address here, which marks down how much of the credit limit the customer already used this month, which is €50. You can notice that there is a minus, which is just an implementation detail for me, but you can design it in a way that you would have plus here, for example. And then there is the default address of the account, which is the customer-owned money, which is now 200. Moving on, there is another important part of the account, which is the schedules, which is the schedule that we designed. And you can see it's called Repay Credit here, and next run is scheduled on the first day of the next month at 1 o'clock. And since I created this account just a few minutes before doing this webinar, the schedule hasn't run yet. And it is basically the automatic repayment. Then we can look at the other section, which contains which transfers or money transfers or postings did happen on the account. We can see some money movements from or to or from the account of some kind of money. And we can see that when we try to send, we had only €100 on the account. And when we try to send away €150, which is €50 more that we actually had, we applied the credit limit automatically, which was marked down then to the used credit address. And moving on, another important part of the account are the parameters that we designed, which we can see the monthly credit limit parameter here, which for this customer is set to €200, meaning that this customer has maximum monthly limit of €200 to borrow from the bank to support their payments that they don't have enough funds for. So, as you can see, it works, and we were able to take the product design that we designed within this webinar and translate it one-to-one directly to smart contract code, and then they easily create the account from it. Okay, this was to showcase that this is the way how we do it, and we get actual existing accounts from it. But of course, the bank is a living environment, right, Paul?
Yeah, that's right. So let's say, some genius in marketing has a new idea and says, okay, we want to change the way this account works and we want to add a new feature, right? So, we want to modify the behavior of the account. How does that work?
Yeah. That's completely correct. We should expect that our products of the bank will evolve to follow market trends, to customer preference, or just business model that the banks want to follow, right? So we have to be prepared for that. And to showcase how easily we are able to do this within the smart contracts, let's return back to our product, and let's imagine that our bank wants to add a new feature, which says that in case that customer made at least 10 payments during the last month, so in case that the customer did use our product quite a lot, when there is the time to automatically repay the borrowed credit limit to the bank, the customer only has to repay back the 99% of the borrowed credit limit, meaning that the bank will return the 1% of the borrowed credit limit to the customer as some kind of reward that, hey, you used our account a lot, so we don't have to repay back everything. Of course, this is just a really factured example of some kind of really custom feature that you may want on the account, and in reality the feature may be totally different, but it's just to showcase how easy it is to modify the accounts over time, or the behavior of the accounts. And in order to do this modification, we first have to analyze the place where the modification should take effect, or where the modification should be implemented. So as you know, the feature request is that in case that the customer fulfilled some conditions, they don't have to repay everything back to the bank from the credit limit that they used, meaning that they only have to repay the 99% of the used credit limit, or the bank will return the 1% of the used credit limit back to the customer. This is something that is a part of the scheduled event that we have for the automatic repayment of the monthly credit limited customer borrowed. So if I know that this is a part of the repayment schedule, I know that the scheduled event hook is the place where to modify the behavior of the smart contract, and where to add this custom logic. So we will leave the rest of the smart contract as it is. So if in case the customer did use some credit limit over last month, we will repay it. And then we will add additional code, an additional part of the logic that did customer made at least 10 payments last month? If yes, then return the 1% of used credit to the customer, which again is implementable by performing an internal payment from the bank back to the customer that would contain the 1% of the credit limit that customer used, and will be paid back to the customer funds. And I am actually quite I am able to evaluate if customer made at least 10 payments last month quite easily within the smart contract, because if you remember, the smart contracts have real-time access to the account financial data, current and also past balances and payments. So I will just fetch this data and ask if the number of payments was at least 10, for example, and if yes, then I will do the internal payment that will move the funds from the bank to the customer to repay the 1% of the credit limit back to the customer. So, to sum up, what is the future-proofness here? Because this webinar is called Future-Proofing Bank Products with Thought Machine. So, the future-proofness, I think from the engineering point of view, was showcased on the example that we provided. But to sum it up and to name it, the future-proofness is mostly the development freedom for me. So, any future business requirement, or even any current business requirement that I have on the product, any feature that I am supposed to be implemented, I know that I don't have to worry about if it will be possible, if the technology won't limit me anyhow, if I don't have to spend 3 months or finding some workarounds, because I know that I can write the logic as Python code. I can easily model it with the mechanisms that I showcased to you, and I know that in the future, any change request will come, I will be able to implement it and to model it because of the flexibility of the Python code and of the smart contract. And that's kind of nice thing, because you have a standardized way how to implement your bank product, which isn't limited or doesn't limit you. So that's the future-proofness. I am not scared about the future requirements. But of course, it's not only limited to the development freedom. The future-proofness also I think is nicely shown in the way how I can test the changes, because I know that in the future I will have the control over the changes. In case I will modify a product, I will add a new product, I can easily first test the changes separately then connect the change to the rest of the bank and test it together. So I know that I limit the risk of breaking the whole bank in future in case I modify something, right? Which is another nice way how to be more, how to have more control over the changes you make in future. Then, of course, the deployment is also another point of the future-proofness, because when I'm deploying a new smart contract, I don't have to redeploy the whole core banking system. I don't have to go offline for a week to maintain that and to actually update my whole bank. The smart contracts, if you remember, are deployed as a configuration to the vault core, and there are multiple smart contracts that can coexist at the same time. So I will just add a new version, and I am able to have control over that, do it in a modular way, and to test in the deployed environment that everything works before I actually take the effect on the whole or the rest of the bank. And connected to the modularity within the deployment is also another point of the future-proofness, which is related to the easy migrations that we talk about. So in future, if I will have to migrate the accounts from an older version of the product to an updated version of the product of the smart contract, I know that I am easily able to do so just by setting the new version of the smart contract for given account, and I have a great level of monitoring and automatic monitoring. If something goes wrong, then it will notify me, and I can react to if anything goes wrong, and I can automatically migrate the accounts to the older version back, so I can quickly fix the bug without interrupting the production and actually going offline for a week. So that's also really, really nice. And all these points of view or all these benefits that I see here are for me the part of how I think that my banking products will be future-proof.
Very good. Very interesting. I think the piece that jumps out at me the most is the migration, Veronika. I love that idea that you're able to migrate new accounts one by one, and have different accounts on different versions of the same type of account. Very different to legacy systems.
Yeah, that's correct. It's really quite assuring. As an engineer, I really, really like that feature.
Okay. Well, we've done quite a few Thought Machine implementations at this stage. Probably worth jumping on to the next slide. We've done quite a few Thought Machine implementations, and we've done it on, I think, 3 different banks now. So we've actually, at this stage, developed a number of propositions around Thought Machine, around application architecture, around infrastructure development, and particularly around smart contract development. And I know, Veronika, you've developed a whole bootcamp around this to train people up in terms of how to design and build and test smart contracts, so that, we can not only do it for our clients, but we can also train their in-house staff in terms of how to do that. And those 3 offerings sit within our broader offering in Vacuumlabs around end-to-end software development. So if anybody's listening or watching this today, and you're thinking about using Thought Machine or to build a bank or a fintech product, then we'd be very happy to talk to you some more and see if we can be of help.
Yeah, thank you, Paul. And with that being said, we made it, and we successfully went over the whole webinar and the presentation. And I hope that you learned something new today, and you learned more about how bank products can be developed, and it doesn't have to be just a way full of pain, but it could be actually quite nice, modern, and flexible. And in case you would have any questions or would have some topics that we can help you with or you would like to discuss it with us, feel free to reach out to us. And so thank you for the attendance. And we have the last slide here, which contains our contact information and links to our LinkedIn profiles, as well as a link to a website with more information about how we partner with Thought Machine to create modern banks and banking products. So feel free to reach out to us, to connect with us, or to check out more information about how we create the bank products on the page. Thank you for your attention, and have a nice rest of the day. Bye.